We're now at lesson 15E, and it is the conclusion to several lessons that we have been working on. In a recent study on helping obese people with diabetes, a group with type 2 diabetes was divided randomly into 3 groups. A third of them received gastric bypass surgery, in which most of the stomach is surgically bypassed. And another third received a surgery called sleeve gastrectomy, in which most of the stomach is surgically removed. So far we have bypass, we have removed, and then the remaining participants were treated with medication alone. First question, is it observational or experimental? And as we've been doing all semester, make sure you hit pause, answer a lot of these questions, and then come back and do them with me, make notes, be preparing for the next test. We finished test 3, test 4 is going to be coming up, and our final. So make sure you're making the most out of the videos. So is the study observational or experimental? When you're manipulating something, it's experimental. So the objectives for this lesson include, and I want to note the first 2 in a big way. In observational studies, and keep in mind this is saying observational, blocking can be implemented to help control confounding variables. This strategy can make associations more certain, and the conclusions should not imply cause. In experimental studies, blocking is implemented to make the study more sensitive to change from treatments. And now we get to say causation can be inferred. We'll also be able to make appropriate conclusions from these observational and experimental studies, and we can identify problems in studies. Got to be looking for problems that are going to prevent us from making inferences to either populations when we have an observational or treatments when we have an experimental. Question number 2. More than 33% of those who had the bypass surgery met blood sugar targets after 3 years, compared to 24% of those who had the sleeve gastrectomy, so that's where they remove, and just 5% of those with medication alone. For either surgery, the proportion of those who met blood sugar targets was significantly higher than those on medication alone. So in these questions, make sure you're spending time thinking and pondering information before you listen to the video, especially like on this first one. Would it make sense to implement a control group with a placebo for blinding this surgery? Lots of different answers that you could come up with, but remember the first 2 were surgeries, and for it to be a placebo, then the third group, the control group, would have to have a surgery where nothing is done. And trying to replicate this without having a surgery would be extremely difficult. So part B, is it possible that the placebo effect was the cause of the results observed? Explain your answer. And some things and thoughts you might consider putting down are that the response to the medications may have been a placebo effect. That is possible. There was probably some placebo effect in the responses to the surgery. But since both procedures were surgical, the placebo effect does not explain that there were better results for the gastric bypass. So jot down some ideas and thoughts about whether you think that there was not a placebo effect. And then finally, on this little part, would it make sense to implement blocking to minimize variability within treatment groups? And if you think so, then what kind of blocks would you suggest? Again, make sure you're spending some time to think on this, because when you think about weight loss or medical issues and you think of some possible differences that might occur with different groups, it might make sense to separate the men from the women to reduce variability. It might also make sense to block by age group as well if there were variabilities by age, like some young people or some older people. Moving on, it says that the study did not have a typical control group. Again, remember, we had 2 surgeries, and to fake a surgery would be pretty much impossible, and then to just cut somebody open and sew them back up doesn't sound very ethical. So if patients are very ill, we do not want to give them any treatment at all. I'll get back to the control group. So let me say it again. If patients are very ill, we don't want to not give them any treatment at all. So in such a case, the control group is a group that gets the traditional treatment, such as the group in the study who received medication rather than one of the surgeries. So Part D, taking any weaknesses of this study into account, the fact that we didn't really have a real control group, and write a conclusion that has multiple sentences, like where you are addressing the effectiveness of each treatment in the study. So probably at least 3 sentences, 3 parts of description. And so I'm going to number just as I talk, because you might say something like, there is evidence that the gastric bypass surgery was most effective in helping recipients meet blood sugar targets after 3 years. You might also want to write that there is evidence that the sleeve gastrectomy was effective, but less so than the gastric bypass. And number 3, the placebo effect may be contributing to the effectiveness of both of these surgical procedures, but it does not explain the higher result for the gastric bypass. And something else you may want to consider writing. There is no way to determine if the medication is effective without a control group. The outcome could be entirely due to the placebo effect. These are just some things and thoughts that you may want to write. Write your thoughts and practice like what you would be practice writing for the next test on how you would write down what you think is effective, some really fluff words, catchwords that you might say, some safe words, because even though this was an experiment, I don't know that we've controlled for enough to say that we are that the surgery causes the diabetes numbers to go down. So we have more reading and writing, and I had mixed reviews in class today giving back test 3 because several students liked the test with more writing and several students did not. So we're almost done with the writing, so that's good news if you don't like it and bad news if you do. But right now we still have some more reading and writing. So on question number 3, it says there was a recent sample of 2,700 men and women from the United States for 25 years. This research was a part of the coronary artery risk development in young adults study. One of the conclusions from the study was that those participants who exercised as teens and as young adults performed better on memory and problem-solving tests when they got to middle age. These results occurred even when blocking was implemented to account for unhealthful factors like smoking, diabetes, and high cholesterol. The sample included people of several, not all, keep that in mind, ethnic backgrounds from the United States. These groups and their subcategories, gender and age, were selected in proportion, matching the population. Yay! Part A, was the study observational or experimental? And with nothing being manipulated, we only observed. So Part B, can we use the results of this study to make an inference about all people who live in the United States? Because they have done a really good job, a lot of good things in this study. And if not, then to whom can these results be generalized? They were very clear in their study that there are some ethnic groups who were not included in this study, so they're not represented. However, the results can be generalized to the collection of groups that are represented. They didn't list them for us, but they did a good job of telling us what they did, how they did it, and what they didn't do, what they left out. So we have some parts of this that can be generalized to whom they represent. Part C. What does it mean that blocking was implemented to account for unhealthful factors such as smoking, diabetes, and high cholesterol? It means that smokers were isolated in a block, and those who exercised as teens and young adults were compared to those who did not exercise. The same would be done for people who have diabetes, they were blocked, and high cholesterol, they were blocked. And so what's happening is you have a smoking group of exercise and not exercise, a diabetes group of exercise and not exercise, etc. High cholesterol of exercise and not exercise. And so then it says, can we conclude that exercising as teens and young adults caused better problem solving and memory skills in middle age? If it's not causal, can you offer an alternate possible explanation? Well, we got to be real careful with that C word. So we cannot conclude a causal relationship in this observational study because it's an observational study. There may be another variable or other variables that cause good exercise habits and better problem solving and memory skills to occur together. And one thing that seems to come up in our classroom discussions and in these lessons is education. Because it may be that more education led people to exercise more, and also because they were in school, to have better problem solving skills as they got older. So what can we say? We can say, remember all those fluff words I keep asking you to write down? People who exercised as, and I'm not on the right screen, but I can use this. People who exercised as teens and adults, and now you can't read that, but as teens and adults, tended to have better problem solving and memory skills in middle age. The end. Except I have some information that I want to make sure that you have in your notes. I've been asking you to keep flashcards or a glossary list or some kind of electronic document on your phone or computer. And there need to be a lot of pieces of information in there about observational studies and representative samples and generating random members, stratified sampling. All of these things need to be in your vocabulary and the specifics of it, like what is error? What is sampling error? What is non-sampling error that includes bias? And when we do experimental studies and we apply treatments, we're trying to infer about a treatment, but then there are these things called confounding variables, and we can help isolate them with random assignments and try to have control groups, try to have placebos, blind and double-blind studies, and realizing there's this thing called placebo effect. So being aware, reporting just as they reported a while ago that they had not included all ethnicities. And then there was this other thing that we talked about called blocking. And then sometimes what we're studying has natural differences. And then it makes sense to go ahead and create some blocks and then run like mini studies on each one of those, MINI. And then that means they're divided in treatment groups and control groups, and they're tested separately. Anyway, all of that to say you have a lot of vocabulary, and in our test 4, you will see lessons 14 and 15. But the good or bad news is that this lesson wraps up the series on statistical study design. Go look at your syllabus, see if you have more lessons for this week. If you do, keep going. If you don't, go do some other homework. I'll see you in another lesson.